Welcome back to the GCSE Maths Pro YouTube channel. Today's video is on composite functions. This is part 2 in the functions series. You should have already checked out the first video on normal functions. Really quick video, but it's just to get you into the idea of what functions are, and then we can lean into this next video. So let's jump right into it. Composite, or sometimes I guess we can use the word compound. You might have heard it in terms of shapes when they say compound shapes. Compound shapes is where you might have two different shapes or multiple different shapes stuck together, isn't it? So for example, sometimes you have two rectangles stuck together to make an L shape. It's called a compound shape or a composite shape. So it's basically a few things kind of stuck together, really, is what we're saying. And you'll be able to see it here when we read out this question. And as I said in the first video, obviously functions can be defined most of the time by f of x, but if they've already got one function in the question and they have a second one, they obviously have to choose a different letter. So in this case, you're going to see f of x and g of x, because we will always have two functions in each question. So given that f of x is equal to 2x plus 3, and then g of x is equal to x minus 7, obviously these are two separate functions, they want us to find f of g of x. So you can see what I mean by composite or compound. They've taken the two separate functions and effectively they want us to kind of put them together, right? So f of g of x. So what we're going to do, and the main thing you need to remember, is we're going to substitute one of the functions into the other. But which way are we doing it? If you've got it this way around, we're always going to be substituting the middle letter back into the first letter, or in this case, the middle function into the first function. So I always imagine this arrow. It's always going backwards. What I mean by that, okay, is that I'm going to take the whole of g of x, the whole of this function, and I'm going to substitute it in to where the x is on the f of x function. Now, it's kind of a weird concept to grasp initially, but if you remember in our first video, we were effectively substituting in numbers, weren't we, to where the x was. Now imagine that instead of a number for x we're substituting in, we're just taking this whole other function and substituting it in. So f of g of x basically is, I need f of x, but wherever there's an x, I'm going to replace it with the whole of the g of x function. So imagine I write it like this. Okay? So we've got two lots of g of x plus 3, and obviously g of x, that function is x minus 7, isn't it? So do you see how I'm literally keeping the other numbers of f of x, but wherever there's an x, I'm replacing it with the other function as a whole. Obviously now I'm going to expand and simplify. This is just expanding brackets, isn't it? So 2 times x is 2x, 2 times minus 7 is minus 14, and we still have plus 3 here. Now we can just collect the like terms. So minus 14 plus 3 is minus 11. So that's your answer. So f of g of x is 2x minus 11. I've basically combined the two equations together, but it's really important that you pay attention to which way round the letters are written. So we're always working backwards. We're always going to put, in this case, g of x into f of x. So we've got exactly the same question now, just so that you can compare them. However, do you see how it now says find g of f of x? It's now the other way round, isn't it? Let me go back so you can see. The first one we did, what is f of g of x? So we put g of x, we put the g function into the f function. Now we've got the f function that we need to put into the g function. So now we're going to take the whole of f of x and we're going to put it into where there is an x in the g function. So we're always working backwards. I think you can kind of understand what composite functions are, but it can be quite difficult to remember. Okay, I remember that one has to go into the other, but which way round is it? It's always backwards like this if you imagine this arrow. So the f of x is going into the g one this time. So if I write out g of f of x is effectively like writing, in this case just x, isn't it? So f of x minus 7, isn't it? In which case f of x is 2x plus 3, and then we still have that minus 7, don't we? So now I can just simplify. So 3 minus 7 is minus 4, so 2x minus 4. So g of f of x is 2x minus 4. And if I go back again, f of g of x is 2x minus 11. Okay, so hopefully that's kind of clear. We're substituting one whole of the function into the other one, and you just have to remember which way round you're going to do it. Okay, it's always backwards. Okay, so we're going to use the same example again. However, we've already seen how to substitute f into g and g into f. They could actually ask you to substitute f into itself or also g into itself. So you can see here we have find f of x. So I don't even need g in this question actually. I'm just going to take the whole of f and substitute it into itself basically, isn't it? So f of x is equal to, obviously the main structure is the 2 and the x, which I'm going to replace, plus 3, which is the main structure, isn't it? And then I'm substituting it into itself. So where it says x, I'm going to replace it with another lot of itself. Okay, this one's almost, well, it's still the same method, but it's almost kind of harder to comprehend, or it's quite hard to kind of figure out, because it's quite clear when you've got two different functions and you're substituting them into each other. When I'm just taking itself and substituting it into itself again, that can be a little bit harder to understand. However, hopefully that's clear, and also based on how you've already gone through composite functions in the first place in the concept. And obviously now I'm just going to expand it and simplify, aren't I? I've already done the composite function part. I'm just going to now expand and simplify. So 2 times 2x is 4x, 2 times 3 is plus 6, and we have the other plus 3 there. Now I'm just going to collect the like terms. So I've got 4x, and obviously 6 plus 3 is 9. Okay, so that's it. So you're literally doing the same idea, except we're substituting the same function into itself. So we're going to do one final example of that with the same question. So this time though, we're finding g of x. Okay, so we're going to take g and substitute it into itself. So g of x, obviously we have x minus 7, which we need to substitute into x minus 7. So where we have the x, I'm going to replace it with the whole of g. This is a little bit harder to show, but I'll use brackets to show you. So instead of writing x minus 7, the x is where I'm going to substitute in the whole function. Obviously I still have minus 7, don't I? And I'm substituting in g, so obviously that's going to be x minus 7 in the brackets. Obviously if I expand, that's not really expanding, is it? But it's basically x minus 7 minus another 7, so minus 14. So hopefully those two examples are clear enough so that you can see what I mean by this when we're taking the same function and substituting it into itself. Wherever you see the x, that's what we're going to replace with the other function. In this case, it was just the same function, wasn't it? Given that f of x is equal to x plus 1 this time, and g of x is equal to minus 5x, find g of f of x. So first one, I need to realize which one is going to be substituted into the other. Well, it's always backwards. I'm taking f of x and I'm going to put it, the whole of f of x, into where the x is. Okay, I'm writing this out fully. You don't have to necessarily write this first line of working at all. I'm just doing it to try and hopefully make it more clear. In this case, we have minus 5, and then f of x, the whole of f of x is multiplied by the minus 5, isn't it? So minus 5, I'll put a bracket, times the whole of f of x, which is x plus 1. So I've substituted it in. Now I just need to expand and simplify, isn't it? So minus 5x minus 5, that's your answer. Once you've kind of got the idea of it, it is really straightforward. But as I said, the most important thing is to remember, when it's written a certain way round, which one am I substituting in to the other one? So we're always doing it backwards, so that in this case, the f went into the g. Okay? So let's try another example. Given that f of x is equal to 3x squared and g of x is equal to x minus 2, find f of g of x. So this one means I need to take g and put it into f. So the whole of the g function is going to go into where we have an x in the f function. Okay, so we've got f of g of x in this case is 3 g of x, and then this is squared, isn't it? The whole of this squared. Okay, so I've got 3, then x minus 2 squared. Now it's just the x that was squared, wasn't it? Not the 3. So I'm going to square this and then multiply everything by 3. But I know I've mentioned in other videos, remember, this is not just, oh yeah, x squared and then minus 2 squared. No, this is effectively double brackets, isn't it? So don't forget the middle part. So it's like writing this, x minus 2 and then another x minus 2. And we're expanding double brackets, aren't we? So leave the 3 there for now. I'm just going to expand the double brackets first. So I've got x times x, obviously x squared. X times minus 2 is minus 2x. Another minus 2 times x, so minus 2x. And finally, then we do have the minus 2 times my minus 2, which is positive 4. And if I'm going to just simplify that middle bit, I've got x squared minus 4x plus 4, haven't I? Now I can expand it by multiplying all of those terms in the bracket by 3. I'm just going to put it over here. I've got 3x squared minus 4x times 3 is minus 12x, and 4 times 3 is plus 12. So there's my answer. Okay, so it's only really this line here that is the functions part, the composite functions part. The rest is then you just doing normal algebra, so maybe expanding brackets, simplifying, that kind of thing. It's literally just substituting one whole function into the other. That's literally all it is for composite functions. Okay, if you feel like you've got the idea or you've got the hang of it, pause the video, try this one out yourself. It's a little bit more complicated. However, it's still the same method, okay? So let's go through it. Given that f of x is equal to 2x minus 4 all over 2, and g of x is equal to x squared plus 5, find g of f of x. So remember, we're always substituting in backwards to the order that's there. So I need to take the f and substitute it into g. So the whole of f, I need to substitute into where it has the x in the g function. So g of f of x is effectively, in this case, like doing f of x squared plus 5, isn't it? That's basically what we're doing. So if I actually put f of x in there, I've got 2x minus 4 over 2 squared, all of that squared, and then I still have the plus 5 at the end. So again, when I'm going to square this, I need to square the top and the bottom of the fraction, but the top of the fraction is effectively like double brackets, isn't it? So I've got 2x minus 4 times by another 2x minus 4. Now the denominator is just 2, so 2 squared is just 4, that's fine. Plus 5 on the outside. And now I just need to expand my brackets. So 2x times 2x is 4x squared. 2x times minus 4 is minus 8x. Obviously, same thing again, minus 8x. And finally, minus 4 times minus 4 is plus 16. All over 4, plus 5 at the end, don't forget that bit. Now I'm just going to bring it up here to simplify. So the middle terms, the x terms, are like terms, aren't they? So I can actually have minus 8x minus another 8x would be minus 16x plus 16 over 4 plus 5. Now, I can actually simplify this fraction because if all of the terms have a common factor, you can divide by that common factor. So, for example, we've got the 4 here, 16, another 16, and a 4. All of them can be divided by 4, can't they? So I can actually get rid of the fraction almost. I'm just dividing the whole thing by 4. 4x squared divided by 4 is obviously just 1x squared. Minus 16x divided by 4 would be minus 4x. And then 16 divided by 4 is just 4, isn't it? Plus 5. And finally, now I can actually add the 4 and the 5, because those are also like terms, aren't they? We've got x squared minus 4x plus 9. There we go. That's the most simplified. The actual functions part is just this line here, really, isn't it? The rest of it is actually expanding, simplifying, and so on. That's just algebra at the end of the day, isn't it? Okay, so now that hopefully you've got an idea of what we mean by composite functions, we're now going to combine two things. We've got composite functions, but we also now have a number or a value for x, which you will have seen in the first video in this series, how to deal with when we have a number in the brackets. So there's kind of two ways you can do it, you just have to choose which you like better. You can deal with the fact that we've got the composite function first, then substitute in 2 at the end, or you can substitute 2 into the first function, which in this case is the g, work out what that is, and then substitute that number into the other function. It's up to you which you prefer. I'm going to actually show you both so you can then decide, okay? Okay, I've just put a line in so you can see both options. So let's say option 1, which is more consistent with what we've just been doing. Let's say we work out the composite function first. In this case, it would be f of g of x. And as we said before, we're working backwards, aren't we? So we're taking g and putting it into f. So the whole of g, so that 6 minus x goes into where there is an x in the f function. So here we've got basically the whole of g of x but squared, haven't we? Okay, that's fine. Now you might want to expand that, you might want to just leave that like that. There's just so many ways to do it, it's up to you, but let me just say if I expanded it. As I said, that's double brackets, isn't it? So we're going to have 36 minus 6x minus another 6x plus x squared. Now I'm just going to rewrite it to put the x squared first because that is normally how we have a quadratic, isn't it? And I'm going to simplify the like terms here. So minus 6x and another minus 6x is minus 12x plus 36. I've just written it the other way around, so I've got the x squared first. Then what you can do is then go, oh, I actually wanted to find out what is the value of f of g of 2. So when x is 2, what does that equal? So as you have seen in the first video, that just means where you see an x, you put a 2 in this case. So we've got 2 squared minus 12 times 2 plus 36. And you just work that out. If it's a calculator question, obviously just put it in the calculator. So we've got 4 minus 2 times 12 is 24 plus 36. So 4 minus 24 is minus 20 plus 36 is 16. So the answer is 16. This option is more consistent with what we've just done. It's kind of like do what we just did, what we've just learned, and then add an extra step. The other way to do it is to deal with, let's put option 2 first. There, so option 2 is to say, right, let me just deal with the fact that I've got g of 2. Okay, and that just means, well, g as a function is 6 minus x, so I just need to do 6 minus 2, which is 4. Then I just need to put that value into the f function. Again, we're still doing it in the same order, aren't we? We're doing g first, then into f. And f is 4 squared. 4 squared, which is 16. Now you see it's a lot faster. a lot faster. So you might prefer option 2, that's absolutely fine. Or you might prefer option 1 because at least then it's consistent with what we were doing when we were working out without any value of x. Completely up to you, whichever you prefer to do is what you've got to go with, okay? Obviously here I've written a lot of steps of working out. You might be able to do this option with, half the steps of working out. That's absolutely fine as well. So pause the video, try this one out yourself, choose whether you want to do option 1 or option 2. It does not matter, you'll still get the same answer. Okay, so I'm going to work through option 1 first. So we've got here, given that f of x is equal to the square root of x plus 4, and g of x is equal to 2x, find g of f of 21. So first we're doing the function of f into g, aren't we? So the whole of f is going to go where we see an x in g. So we would get, what's that, g of f of x would be 2 times root x plus 4 basically, isn't it? Then you could sub in the number, which is 21. So we've got 2 root 21 plus 4. Now you can see that that's going to make root 25. We can square root 25 to get 5, so it's effectively 2 times 5, isn't it, which is 10. Okay, that one didn't have as much working out to do algebraically. So that was effectively if you chose to do option 1. Option 2 is if we go, right, okay, we need to work out f of 21. What's that value first? So the square root of 21 plus 4, which is basically what we've just done here, isn't it? So you can see that that would be square root of 25, which we know is 5. And then you would say, right, then I need to take this and put it into the g function. So 5 into the g function is 2 times 5, which is 10. This one actually you can see is very, very similar. The previous one, it did save us a lot of time if we did option 2. This one, however, it's kind of similar. There wasn't as much working out to do algebraically, was there? So you can see that sometimes it's basically the same thing. Okay, so as we saw in the earlier questions, you could have a situation where you need to find a composite function where it's just both itself, isn't it? We're going to substitute f of x into itself. So here we have, given that f of x is equal to 5 minus 2x over 3, find f of 19. So again, I'm going to start just by substituting 19 in, just so you can see that example. So just normally f of 19, don't worry about the composite bit just yet, means I need to replace the x with 19, don't I? So I've got 5 minus 2 times 19 over 3, which if we work that out, 5 minus, well, 2 times 19 is 38, isn't it? Over 3, and 5 minus 38 is minus 33 over 3, which obviously then simplifies to just minus 11, isn't it? Minus 33 divided by 3 is minus 11. And then we can substitute that into f again. Now we're substituting in minus 11 into itself. 5 minus 2 times, in this case, minus 11 over 3 gives us 5. And then you see here, obviously, 2 times 11 is 22, but we have negative 2 times negative 11, so that's a positive, isn't it? Over 3. And that's obviously 27 over 3, which we know is 9. So your final answer is 9. Okay, pause the video, try this one out yourself, and then see what you get. So given that f of x is equal to 9x minus 6 all over 3, and g of x is equal to x minus 3 squared, find f of g of minus 1. So we're going to be taking g and putting it into f. We're always going backwards in that order that it's written. So the whole of g is going to go into where we have an x here. Okay, so f of g of x is 9, and then all of g, x minus 3 squared, minus 6 over 3. Okay, this is quite a lot to deal with, isn't it? So in this case, I would say you probably don't want to expand it all out. I would then just go and chuck in the numbers. So what did we have? We had minus 1. So 9 bracket minus 1 minus 3 squared minus 6 is actually almost a hybrid of both methods, isn't it, really? So then I can work out, okay, obviously think about BIDMAS, you've got brackets, indices, division, multiplication, addition, subtraction. So I'm going to deal with obviously the brackets and the indices first. So I've got minus 1 minus 3. Well, that gives me minus 4, doesn't it? Then I'm going to have to square it before I multiply it by 9. So let's bring it here. So minus 4 squared is positive 16, isn't it? So I've actually got 9 times 16 minus 6 over 3. 9 times 16 is 144. Obviously at this point, again, if it's a calculator test, you would have, put all of this into the calculator. You don't necessarily need to write all of these steps out. What I would be careful with, though, is if you were to just type this into the calculator, sometimes there are certain calculators where if you put in minus 4 squared, it would give you minus 16, which is obviously incorrect, right? When you square a negative, we always get a positive because it's effectively like two negatives multiplied together, isn't it? So just be careful with that. I'd probably work this bit out myself and then I would maybe just chuck the rest in the calculator. But obviously I'm writing out every step so you can just see. And in case that it is a non-calculated paper. So 144 minus 6 is 138 over 3. That actually does divide and we get 46. So the answer is 46. Okay, so our next question we've got. Given that f of x is equal to a half x plus 4 and g of x is equal to 2 times x plus 1, solve f of g of x equals 13. Okay, again, if you've seen the first video, you'll have seen where we first went through where we had a value for x. We had a number that we had to substitute in, i.e. a number that was obviously in the brackets. Then we had the option where we weren't told what x was, but we were told what the whole function would equal to. So you can see here we've actually got an equation. In this case though, we do have a bit more to work out. Effectively, solve f of g of x equals 13 means we need to work out in terms of x what is f of g of x and then put it equal to 13. Then we can solve the equation and find out what x is. So we need to do, first of all, what is f of g of x? We're not substituting any numbers in because we don't know what x is, do we? We're trying to find that out. So we need to put g into f. So the whole of g is going to go into where we have an x in the f function. So we've got half, and instead of x, I'm replacing it with the whole of g, which actually we're going to need square brackets because g already has a set of brackets, doesn't it? So half times 2 times x plus 1, and then we still have the plus 4 in the end. Don't forget they have any extra pluses or minuses because it can be quite easy to forget that they're there. What I would do now is I'd probably expand everything out just to simplify it. So a half times 2 just cancels out, doesn't it? Think about it, 0.5 times 2 is just 1, i.e. it's just not really there, is it? So actually that just ends up being x plus 1 plus 4, so that's therefore x plus 5. Okay, that's simplified quite nicely. Now, because we know that f of g of x is equal to 13 as well, it's equal to x plus 4, but it's also equal to 13, therefore we can create an equation, can't we, where we say x plus 5 is equal to 13. Once we've done this, it's not even functions anymore, is it? We're just going to solve this equation. So I need to subtract 5 because obviously as a linear equation I need to get x on its own, don't I? X equals 13 minus 5 is 8. That's your answer. So again, it's kind of the reverse of what we were doing in the previous few examples. The few examples we just did, we were given what x is. We had to find out then the answer. In this one, we've been given the answer. We had to work back to find out what x was. Okay, so sometimes they'll get you to solve an equation with functions as well. Okay, if you feel like you are happy with what we just did in the previous example, give this one a go as well because it's another equation to solve. So given that f of x is equal to minus x plus 6 and g of x is equal to 2x squared, solve g of f of x is equal to 32. So as I said, first we need to work out an expression for g of f of x, which is where we work backwards. So we're going to put f, the whole of the f function, into where we have an x in the g function. So let's do that first. So g of f of x is the same as we've got 2, and then in those brackets we're now going to put minus x plus 6 squared. Now I might just expand and simplify it first. You can put it equal to 32 now if you like, but I'm just going to expand and simplify first. So as we said, that's like double brackets, isn't it? Minus x plus 6 and then minus x plus 6 again, and then multiply everything by 2 at the end. I think that's the easiest way to do it. So minus x times minus x is positive x squared. Then we've got minus x times 6, which is minus 6x, another minus 6x, and plus 36. Now before I times it by 2, I'm going to simplify those middle terms. So minus 6x minus another 6x is minus 12x, plus 36, and then I can times everything by 2. So 2x squared minus 24x plus 72. Okay, now I know that if that's g of f of x, but I've also been told that g of f of x is equal to 32, I can create that equation, can't I? I can then say, right, 2x squared minus 24x plus 72 is equal to 32. Okay, so this is kind of like step 1, and then this is step 2. Now we just need to solve this equation. Now as you can see, this is a quadratic equation, isn't it? We've got an x squared, so we're not going to be doing the same as before where we had to try and isolate the x on its own. When we try and solve quadratic equations, we have to get all of the terms on one side of the equation and 0 on the other, and then hopefully we can factorize, so put the brackets back in. So in this case, I'm going to move the 32 across because I want everything on one side. So subtract 32. So I get 2x squared minus 24x plus 40 equals 0. Then you can factorize it like this if you like, but I'd like to make it easy for myself. Do you see how all of these three terms are divisible by 2? So I'm going to just divide everything by 2 because it's kind of like simplifying fractions. It's still the same fraction, I've just made it a smaller version, haven't I? I've got x squared minus 12x plus 20 equals 0. Now that's just easier to factorize because I don't have a number in front of the x squared. Now to factorize, I need two brackets. Equals 0. So I've got x in both brackets. We're multiplying to make a positive, but when I add them, I get a negative, right? So I know I need two negatives. So factors of 20 that would add up to 12, well, that's pretty straightforward, isn't it? 2 and 10 would make 12. Now to solve it, remember that we're basically saying these two brackets are multiplied together, aren't they? We've got x minus 2 times x minus 10, and it equals 0. That's where the 0 is very important, because how do you multiply two numbers and get 0? You have to have at least one of those two original numbers being 0 itself, don't you? That's the only way to get 0. But we don't know which of these two in the brackets is equal to 0. So we're just assuming that let's just see if it's both of them. If x minus 2 is equal to 0, do you see how I would then get, that's just a linear equation now, isn't it? I would then add the 2 across, wouldn't I? Therefore, x equals 2. But I don't know, it could be the other one, or x minus 10 equals 0, and therefore I need to add the 10, don't I? Hopefully this doesn't come out the side of the screen. So x is equal to 10. So let's just highlight those. Here are our solutions. With quadratic equations, you should get two answers. Okay, so we've got x is equal to 2 or 10. Because there's no actual context, we don't know which is right, so you just leave both of them, okay? So this one, we just actually had to solve a quadratic as well. You can see that factorizing quadratics and solving quadratics doesn't just come up in literally a question for that, it can come up within other topics as well, within other questions. If you want to recap how to factorize quadratics, I'm going to link the first video now and all of the series in the description, so check those out because factorizing quadratics is super important for the whole of the syllabus. Okay, so those are some really good examples of composite functions. We've gone through how to work out a composite function, what to do when we're actually given the value of x, we need to substitute it in, and what to do when we've got an equation with a composite function. The next video is then inverse functions. So check that one out next. Thanks for watching this video and leave any questions you have down below in the comment section.